megawatts of nominal power. This one's 1 megawatt. However, that's its nominal power. Its average power delivery over 10,000 hours of operation is 220 kilowatts.
25% was the front.
So, do you remember we looked at the cost of energy and the capex?
Another reason why you saw it.
Right, you got it.
Yes.
Exactly. It's way too expensive. And I mean, it's beautiful. Look at it. It's in its finery, it's in its
From an
paint.
engineer point of view, but from a financial point of view.
From a financial point of view, it's a mess. It's dreadful.
No.
And what we did is we invested £1 million in that company to find out if there was some way that that technology could be cost effective. But when you're designing for 1 megawatt and you're getting 220, there's no way you can do that. There's no way. Now that 220 is the theoretical power delivery over a period, 10,000 hours. When they actually measured it, they got 60 kilowatts. So not even as much as a car engine. Okay. And that was for a number of reasons, mostly to do with reliability, because they actually found that 1 megawatt device was subjected to 2 megawatts. So then you have this horrendous calculation. 2 megawatts, theoretical 220, actual 60. And I don't know of an engineering structure on the planet that could do that. When you have that sort of a ratio of 38 to 1 between its nominal working and its extreme. It's incredible. So what we're doing next is to look at new technology. What could be done? Because there's a lot of wave energy there. All around the world, especially in the southern hemisphere. You look off the coast of Chile and Australia or South Africa, there's huge wave energy. It's not, we should be able to find some way of doing that. So what we're investing in next, or what the Offshore Renewable Energy Catapult, which is another organisation, is investing in, is looking at these new technologies. So new materials, looking at using electrically activated polymers, for example. So this is a device that directly converts mechanical strain into electrical energy. And that shows a lot of promise. And the best thing about that is that most of the material is recycled. Yeah, so it's extremely cheap. And of course, being rubber, as we know, you can pull rubber to 300% its nominal strain. So I think there's a good future in that type of understanding. However, it's got to be better than that.
So you're probably not going to continue building those. This was just a test.
That company has now gone into receivership. It's been closed down.
Right.
Yeah. It was a nice exercise. That's it.
It was an extremely good learning.
Yeah.
Because if we hadn't invested that money, we wouldn't find out, and we could have carried on trying to make machines out of steel, and hugely complicated hydraulic systems.
Not Pelamis. They went bankrupt.
They went bankrupt in December.
There it is complete.
There's a picture of it there. It's there's no people standing next to it, so you can't see the scale. Exactly.
It worked like that.
On the bottom picture, you can see the other type of device, which is called aquamarine oyster, and it is.
And it's constantly doing like
It's that.
Yeah.
Yeah. So it's a flap or a paddle, and it just moves in the waves, and it drives hydraulic fluid from one place to another. That then drives a generator inside. But look at the size of that. Can you see the gentleman there on the right hand side? That's
another monster.
it's huge. It's nearly 5,000 tons.
Everything is huge.
It's
for marine.
Yeah, for marine everything. Yeah.
Everything is huge.
But if you think about it, though, I mean, the tidal stream one makes much more sense because it's a bit like ship's propeller with an electric motor on the end. It's today's technology. We've already got that. So. And we know that we can make those things. It's shipbuilding. We've been doing that for 200 years. So that's much easier. Wave technology there's nothing really similar, is there? So everything is custom made, and that makes a difference. But we've got to get the principles right first. So if you have any ideas on this, let us know. And we'd be very happy to try them out, that's for sure. Okay, some of the projects that we have done to look at marine energy. We've developed a mains plug that will operate underwater. It's a 3-pin plug and it will operate underwater. Because if you can't connect the devices to land, you can't connect the devices to the grid. We've also invested in a 1 megawatt tidal stream device. So that's in service and has been in service for 2 years. It already meets the cost of energy target. So we're very, very happy with that one. It was made by Alstom, and the same type of machine. It's starting to go. Down.
Maybe under.
Ah,
A ver, hay que meterse por abajo para enchufarlo.
Mira, ¿dónde